Hello everyone, this is Imran Pardesi sir and today I will be teaching you standard 10th math 2nd chapter number 3 circle. In circle today we will see the next theorem and that is theorem of touching circles. Okay, so in this theorem you will see the two different methods. Two circles touches externally. Can you see over here? This is bigger circle, this is smaller circle. These two circle touches externally. Okay, then the second condition, these two circles will touches internally. Is it clear? So now I will explain you what this theorem is all about. Please look at the board. Dear students, theorem of touching circles, this is very much important for your practice set 3.2. If you understand this explanation, you will solve easily practice set 3.2. So please look at the board here. Now the theorem is, what will be the theorem? If two circles, see these two circles touch each other, their point of contact lies on the line joining their centers. Okay, these two circles touches externally, these two circles touches internally. Okay, and their point of contact, can you see point C is the point of contact. Okay, here also and here also, can you see these two circles touches here, the point of contact is point C. Okay, so point C will lie on the line joining their center. See, this is point A is the center of bigger circle, point B is the center of the smaller circle. Okay, if you will join these two circles, center of these two circles, then it will pass through this contact point. It means these 3 points will lie in a line, or these 3 points will be collinear points. Okay, see these two circle touches externally, and can you see this one tangent is passing through? Yes, so this tangent will be perpendicular on this radius AC to this radius AC. Yes, this tangent is perpendicular to the radius BC as well. Okay, now you have to see, you have to go through these main points. Look at here, point C, point of contact. Point C is a point of contact. Here also in the externally touches also, and in internally touches also, point C is the point of contact of two circles with center AB. A is the center of bigger circle, B is the center of smaller circle. Here also point A is the center of the bigger circle and point B is the center of smallest circle. Okay, now point C lies on the line AB. Point C is lying on the line AB. Okay, how? Segment AC. AC is perpendicular. Can you see this T? Can you see this T like this T? It is perpendicular. Why it is perpendicular? A tangent at any point of a circle is perpendicular to its radius. So here also it will be perpendicular, here also it will be perpendicular. See, segment AC perpendicular line L, AC perpendicular to line L, this is line L. Now see segment BC, BC also perpendicular on line L. Okay, through C only one line perpendicular, through C only one line perpendicular to line L can be drawn through C, here or here. Is it clear? So points C, A, B are collinear. That is A here, A, C, B, A, C, B, collinear points. In this condition, A, B, C, these three also collinear points. If you will join it, it will be collinear points. Is it clear? I hope you understood here. Now, if the two circle touches externally, so the distance between their centers, this center A and this center B, so distance between their centers is equal to the sum, means addition of their radius. That is, can you see a distance between A and B is possible by adding radius AC plus BC. A to B is possible by adding property, that is AC, radius AC plus radius BC. Can you see here? That is distance between A and B. A is the center of the bigger circle, B is the center of the smallest circle. Clear? So when you have to keep in your mind, if two circles touches externally, we have to do addition of their radius. We have to do addition of their radius when two circle touches externally. So this AB, distance between A and B, is equals to AC plus BC. Clear? When the two circle touches internally, so at this condition we have to do difference between their radius. Okay, distance between their center is equal to the difference. Difference means subtraction, minus of their radius. That is difference between AB. Difference between AB is equals to AC is the bigger radius of bigger circle and BC is the smallest radius of the smallest circle. Okay, so AC minus BC. See, AC minus BC, bigger radius minus smallest radius. Is it clear? So what did you understand here? When two circles touches externally, we have to find the distance between two centers. Okay, distance between the two center will be equal to their sum, their addition. We have to do addition here. AC plus BC, that is the distance between A and B. And here, if the two circle touches internally, we have to do the subtraction, difference between their radius. That is difference between AB is equals to AC, bigger radius minus smallest radius. I hope you understood the introduction. Now we will start the practice set 3.2, which is related to these two theorem. I hope you understand. So dear students, now we will see the practice set 3.2, question number 1 and 2. It is totally very much easy based on the explained theorem. So please look at the board. See, the question number 1 of practice set 3.2 is two circles having radius 3.5 centimeter and 4.8 centimeter. It means one is bigger circle, one is smaller circle. So the radius of the bigger circle is 4.8 and the radius of the smallest circle is 3.5. Okay. Now we have to see, it is given touch each other internally. Okay. The two circles, they have touched each other internally. It means what? Just now I have explained you, if two circles will touch each other internally, we have to do the subtraction between their radius. Okay. So what is here? See how I will write the solution. I will draw a rough figure. Okay, bigger one radius is 4.8, smaller radius will be 3.5, and this point of contact is C, right? Now I will write two circles with center A and B. A is the center of the bigger circle, B is the center of the smallest circle. Okay, touch each other internally at point C. Okay, clear? Now what things are given? In this question, two radius are given. One radius is bigger and one radius is smaller. So very much easy to you. See, I will use only this ABC in both the figures. So it will be very much easy. Be firm. Okay, so AC, A to C is 4.8 centimeter, bigger radius. And then BC is the smallest radius, 3.5 centimeter. We have to find the distance between their centers. Okay, so distance between A and B, centers name A and B is equals to question mark. So I will write therefore distance between A and B is equals to AC is the bigger radius minus BC, AC minus BC. It means bigger radius minus smallest radius. Okay, so 4.8 centimeter minus 3.5 centimeter, answer will come 1.3 centimeter. Is it clear? So I will write at the end the distance between their centers is 1.3 centimeter. Easy. When the internal you have to do subtraction of between their radius. Subtraction between their radius. Now see the question number 2. Two circles having radius 5.5 centimeter and 4.2 centimeter. Of course, one radius will be bigger, one radius will be smaller. Touch each other externally. So I told you, when two circles will touch each other externally, then we have to find the distance between the centers of these two circles is equal to the sum of their radius, means addition of their radius. Here we will do the addition of the radius, bigger radius plus smallest radius. Is it clear? Now see, I will draw the rough figure. I will show A, B, C only because I will be firm. I will keep my firm alphabets. Two circles with centers A and B. A is the center of the bigger circle. B is the center of the smallest circle. Touch each other externally. Okay, at point C. Okay, at point C they touch each other. See here. Now I will write what is given. AC is the bigger radius, so AC is 5.5 centimeter. BC is the smallest circle, smallest radius, so it is 4.2 centimeter. We have to find the distance between these two centers. So distance between A and B is equals to question mark. I hope you understood. Therefore, distance between A and B point is equals to AC plus BC. 5.5 plus 4.2, the answer will come 9.2, 9.7 centimeter. Therefore, the distance between their centers is 9.7 centimeter. I hope you understood. When the internally will come, you have to do the subtraction between the radius, and when the externally will come, you have to do the addition between the radius. See, AC plus BC. Is it clear? Here you can mention centimeter, no problem. See, 5.5 centimeter plus 4.2 centimeter. So answer will come 9.7 centimeter. Is it clear? This is how you have to solve the question number 1 and question number 2. Very much easy. So dear students, now after question number 1 and 2, we will see question number 3, and here you have to draw. You have to construct. Okay, so this will be homework to you. It is very much easy, but I will show you some hints how to draw. Please look at the board. See, question number 3 of practice set 3.2 is homework, and we have to draw. What you have to draw in question? See, some hints I will give you. In question, 2 radius are given to you. Okay, see here, radius number 1, 4 centimeter, radius R2, radius number 2, 2.8 centimeter. It means one circle will be bigger and one circle will be smaller. Okay, so first, externally we have to draw 2 circles with this given radius. Okay, this is given bigger radius, smaller radius. So first we have to draw, we have to construct externally. So what you will do, you will take compass. In compass you will take 4 centimeter, okay, radius, and then you will keep anywhere and you will construct a triangle. Okay, you will construct circle. Okay, you will take 4 centimeter and you will draw a circle. 4 centimeter, clear? Then 2.8 centimeter you will take again 2.8 centimeter in your compass, and you will keep outside the circle. You will touch it. You will touch the circle here. Okay, you will touch the circle and then you will draw this outer circle. Is it clear? First you will draw. You will take 4 centimeter in compass and then you will draw bigger circle, and then for this smaller circle, you will take 2.8 centimeter in your compass. You will keep outside this bigger circle and then you will touch the circle, bigger circle you will touch. Okay, and then you will construct the smaller circle. Clear? This will be of 2.8 centimeter, and the name of this center will be B. Simple. Now see the internally. Again you will construct, first you will draw the bigger circle of 4 centimeter. First I will draw bigger circle of 4 centimeter. Okay, and then I will take 2.8 in compass. This is the line of bigger radius. This is from A to this point of concurrence C. This point of concurrence will be C. So AC will be 4 centimeter. You will draw circle and you will make this radius line, and on this radius line you will take 2.8. You will take 2.8 centimeter, the smaller radius, and you will keep on that line. You will check the circle should touch it. The bigger circle you should touch it, and then you will draw the internal circle. First you will draw the bigger circle. You will show the radius of 4 centimeter with the scale, and then you will take 2.8 centimeter in compass. On that line you will keep and you will check 2.8 centimeter. You will touch the circle and then you will draw the internal circle. This will be homework to you. I hope you understood how to construct externally and internally circles. So dear students, now we will start the question number 4. I need your very keen attention on this question because it is such a lengthy question. We have to solve 3 sub questions in this question number 4. Very simple. Here we will utilize parallel line, property of parallel line, property of vertically opposite angles. Okay, just please look at the board. Very simple, very easy. If you will focus, you will understand very easily. See here, question number 4. In figure 3 3.27. This is the figure 3.27. Okay, the circles with center P and Q, okay, touch each other at R. Can you see here? This circle is having center P, this circle is having center Q. They touches each other at point of contact. Here R is the point of contact of these two circles. Is it clear? A line passing through R meets the circles at A and B. Can you see a line? A line AB, line AB. Can you see this line AB? Yes. So this line AB is passing through the point of contact R, okay, and meets the circles at a point A and B. See, here it meet at a circle A and here it meet at a point B respectively. Prove that. We have to prove number 1, segment AP means this line AP parallel to segment BQ. This line is parallel to this. Okay, we have to prove that. Second one, triangle APR. APR, P comes in between. APR, P comes in between. Similar to triangle RQB. It means this triangle is equals to this triangle. We have to, this triangle will similar to this triangle. Okay, by which test? We will see later on. Third one, we have to find angle RQB. RQB, this angle, we have to find RQB is how much degree? If angle PAR is 35, means this is 35 degree. Okay, I will mention over there. It is 35 degree here. 35 degree. Okay. PAR. So angle A is of 35 degree. It is given in the question. Then we have to find angle RQB. So RQB is how much degree? See my dear students, in this figure I have made some identical marks. So first I will explain you this, then I will go through the explanation. See here. Can you see these two identical lines? It means PA, segment PA and segment PR, radius of the same circle. So PA is equals to PR. Clear? PA is a radius, PR is also radius of the same circle. Therefore this side and this side will be congruent, equal. So this triangle, can you see this triangle? APR is an isosceles triangle. So these two angles will be congruent. अगर ये 35 का है तो this angle also will be 35. Why? Because these two sides are congruent. So these two angles also congruent. This is 35, so this is also 35. Is it clear degree? Now see here. Now similarly we can see here in this bigger circle. Can you see these three lines here, three lines here? It means QR, segment QR and segment QB. QR and QB are two radius of the same circle. Is it clear? So RQ congruent segment, RQ is congruent to segment QB. Okay, QR is congruent to segment QB. Is it clear? Can you see this triangle RQB then? RQB, this triangle. So this triangle is also will be an isosceles triangle. So if this triangle is 35, this angle is 35. So this angle also will be 35. Why this will be 35? Can you see the X here? X. Can you see the X? If there is a X, the opposite angles, vertically opposite angles will be congruent to each other. Do you remember something? Vertically opposite angles will be congruent to each other if there is a X. Okay. And if there is a Z, then what we will say? Alternate angles. Right? We will say alternate angles. Alternate angles are possible due to two lines are parallel. If two lines are parallel, we can say there will be the property of alternate angles. Okay. So here in this question we will see X. Can you see this X? So if this is 35, this is also 35 because of isosceles triangle. If this is 35, this is also 35. Why? Vertically opposite angles. See X बन चुका है वहाँ पे. Is it clear? Now if this is 35, see, if this is 35, this is also 35, this 35, this is also 35 degree. Why? Because this triangle is an isosceles triangle. Two sides are congruent, so two angles also will be congruent. So my dear students, at last we will see the Z. Can you see the Z? See Z. PAR. Can you see here now? RBQ. Can you see this Z? The Z is forming like this. Can you see this Z? So this angle means A. Angle is 35 degree and this is also 35 degree. It means they are alternate angles. Yes or no? If they are alternate angles, so these two lines will be parallel to each other. Is it clear? So this is how we have to prove. We have to solve the question one by one. Is it clear? Now see here. PRQ. PRQ is collinear points. Clear? Are collinear points. Okay. Now see angle PRA. PRA congruent to angle QRB. These two angles are congruent. Why? X forming vertically opposite angles are congruent. See, vertically opposite angles. This is your first answer. Clear? Now see in triangle PRA, this triangle. In this triangle, segment PA is equal to segment PR. Why? Radius of the same circle. Is it clear? PA is equal to PR, radius of the same circle. So therefore we will say that angle PRA and angle PAR equal, are congruent. Why? Isosceles triangle theorem. This triangle is an isosceles triangle. So this angle and this angle, these two angles will be congruent to each other. So angle PRA, R comes in between, and angle PAR, A comes in between, are congruent. Okay. Similarly, here also we will see the same thing. In triangle QRB, segment QR and segment QB are the radius of the same circle. So this is an isosceles triangle. So this is this angle QRB and angle QBR will be congruent to each other because of isosceles triangle theorem. QRB and QBR. Is it clear? Isosceles triangle, isosceles triangle. So with this, can we say if this equals to this and this equals to this, ये इसके बराबर है और ये इसके बराबर है और ये इसके बराबर है. It means all four angles are congruent to each other from first, second and third. All four. See here also QRB, here also QRB. So QRB take out, all four angles will be congruent to each other. Look at here. Angle PRA, one angle. Congruent to angle PAR, this angle. Now congruent to angle QRB, this angle, because vertically opposite angle. Congruent to angle QBR because this is isosceles triangle. Is it clear? So this is fourth answer from first, second and third. From second and third, all these four angles, see, can you see this identical mark? They will be congruent to each other. Now we can prove that segment AP, okay, see here. So therefore can we see that directly the Z is forming PAR or PAB is congruent to angle QBR or QBA? Yes. Why? Because this is 35, 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 this is 35. So this one and this one also congruent to each other. It is Z. Z is forming like this. So it is alternate angle. See, alternate angle test pass. So we can say segment AP. This AP is parallel to segment BQ. AP is parallel to segment BQ. Clear? First answer you got here. Now we will take the triangle APR, this triangle APR, and triangle RQB, this triangle and this triangle. Okay. First PAR, this congruent to QRB, vertically opposite angle. See here. PAR is equals to QRB, this equals to this and this equals to this. Okay. From fourth we came to know here. Second one PRA is congruent to QBR. All these four angles are congruent to each other. Now we came to know from this fourth one. Is it clear? So therefore we can say these two triangles are similar to each other by which reason? Angle test of similarity. See, APR, this triangle is similar to this triangle. Same conditions are there. So therefore by angle test of similarity, these two triangles are similar to each other. Answer second. Now we have to prove angle RQB. This is how much degree? Okay, we have to show this is how much degree, this angle RQB. this we have to find. Okay, this is we have to find. R cube is how much? So tell me students, this is how much? 35. See here, this is 35 degree. So this is also 35 degree. 35, 35 total 70. And a triangle is of how much degree? 180 degree. So 180 degree minus 70. Answer 110. Very much simple. Look at here. Angle PAR. PAR 35 degree. Okay, given here in this question. Yes. Now we can say all these angles of 35 degree, PRA 35 degree, QRB 35 degree, QBR 35 degree. Yes, all will be 35, 35, 35, 35. Clear? Now we will say in triangle QRB. We will focus here only because we want to find angle RQB. We have to find RQB. Now we will do the sum of all the three angles. Angle RQB, Q comes in between plus angle QRB, R comes in between plus angle QBR, B comes in between is equals to 180 degree. Why? Sum of all angles of a triangle is 180 degree. RQB we have to find. This is 35, this is 35, 180 degree. 35, 35, 70, 70 will go there. It will subtract from 180 and therefore RQB is of 110 degree centimeter. It's 10 degree, 110 degree. So this is how we have to solve the question number 4. I hope you understood. I hope you understood these identical marks and you will solve the same questions in your notebook. So thank you so much and best of luck.